Hello everyone, myself Himank Garg, third year engineering physics student from IIT Roorkee. Today I will be discussing on a topic GPS sensor for my course Applied Instrumentation. Now introduction to GPS sensor technology. GPS stands for Global Positioning System. So what is Global Positioning System? The Global Positioning System, commonly known as GPS, and is a satellite-based navigation system that provides precise location and time information anywhere on Earth. So, explanation of a GPS sensor. A GPS sensor is a device that receives a signal from GPS satellite to determine a precise location on Earth's surface that enables us accurate position, route planning, navigation guidance across various applications. So now we will talking about how GPS sensor works. So GPS sensor works like GPS sensor pick up a signal from a satellite orbiting Earth, and these signal contain vital timing and positional data. So what happens like GPS satellites send electromagnetic signals to Earth. So where the receiver is there, receiver pick up that signal and convert into electrical signal, and using that electrical signal it calculates a position. For calculating position we use trilateration method. So trilateration method is involves measuring a distance from three or more satellites by comparing signal travel time, GPS sensor, and calculate their distance from each satellite. And the intersection of these distance measurement determine the precise locations. So now I will explain how trilateration works. This is 2D trilateration. This is where we are. So this is a receiver. So now we know the location of satellite one. We receive a signal from satellite one. So we know that from satellite one we are on this circle, but we don't know the exact location. So what we do, we give track a signal from satellite two, and from the satellite two, we another draw a circle. So we know that we are on this position and this position, but we also don't know about from where position on which position we are. So now what we do, we take satellite 3 and draw another circle from that. Now intersection of all three gives us a position where we are. So this similar concept used in 3D trilateration, but here is circle, and there is 3D sphere. So now explain how through animation how 3D trilateration works. Now I will be explaining 3D realization through animation. So I told you like we have a 3D spheres. So for 3D positioning, we need latitude, longitude, and altitude. And so yeah, suppose we are here and we get a signal from satellite A. So that now we draw a sphere from that. Similarly, from satellite B, from satellite C, similarly. Now similarly from a D. Point of intersection of these from which we get our 3D positioning, latitude, longitude, and altitude, all. So now I will be explaining about component of GPS sensor module. So here we use Nano 6M GPS module to show you. In Nano 6M GPS module, you have antenna that will connect through a UFL connector, position fixed LED, Nano 6M chip, 3-volt dropout regulator. So what are the basic component of GPS module? So basic component is GPS antenna that receives a signal from satellite, a radio signal, and convert into electrical signal. And what GPS receiver do? GPS receiver takes that electrical signal and calculate positionings, velocity and timings, all other things. And microcontroller is there. Microcontroller is a CPU, central processing unit of GPS sensor module. So it control all the functioning happening inside GPS module, to handling antenna, receiver functionings, all that. And fourth one is memory that will use to store a data of positioning, currently where we are all for all this. And last one is power management to supply a power to all these components. So application of GPS sensor in instrumentation. So we can make a fleet tracking system using GPS sensor. geological surveying system, and agriculture system. In geological surveying, what we do, like in GPS sensor aid in precise mapping and data collection for research and exploration. In agriculture system, we use GPS sensor for farming, guiding when autonomous machinery and cropping monitoring. For these kind of things, we can use GPS sensor. Sorry. What are the advantages of using GPS sensor? First is enhanced accuracy. We can get an accurate result of positioning for improved navigation and tracking systems, and cost saving. This is also cost saving because real-time data help in reducing fuel cost, optimizing operational expenses, all of these things, and improve safety. In GPS sensor enhance safety through real-time monitoring, emergency response, and asset protections. There are different challenges we face using GPS sensor technology. So first was urban challenge. As we know, when we are driving through a highway, sometimes GPS gives us inaccurate results. So due to the dense urban settings and electromagnetic interference, tall building with electromagnetic waves can interface with GPS signal and affect a precision of these. These are some challenges like we face. Uh, these are some challenges. We have many more challenges other than that. These are the major challenges we face in GPS. So challenges faced during a distance calculation. First one is atmospheric layer, instrument accuracy, and desynchronization of clock. As we know, a distance calculation is an important part for calculating position precisely because electromagnetic signal travel at a speed of light which is approximately equal to 300,000 kilometer per second. So while calculating a time uh, to signal travel from satellite to receiver, we need to be very precise. So there are some challenges we are facing. Now we will see through animation how we can overcome that challenges. So first we will discuss about the instrument accuracy. So in instrument accuracy, what happened that we know a signal is travel at a speed of a light, so we must use a clock with enough resolution. As we know, signal velocity is 300,000 kilometer per second, and if 1 microsecond error is there, that will lead to 300 kilometer error, which is very weak so far. So for overcome this challenge, what we do, we use atomic clocks that have with the resolution of nano per second, with maximum error well is 30 centimeter per nanosecond difference, which is totally acceptable for this. Now we will talking about second challenges. Second challenge is desynchronization of clock. Suppose we have a two atomic clock, one at receiver and one at satellite. Because of a high speed relative moving to each other, so we need to consider a effect of relativity. We start a suppose we start a clock synchronously after 1 day. After 1 day, we get an error of around 38.5 microsecond, which will lead to increasing day by day. So that will give very inaccurate result. So to overcome that, what we do, we use we use the theory of relativity to calculate the desynchronization between globe, so that we can electromagnetically adjust them, electronically adjust that values. So now third one is atmospheric layer. So due to the effect of atmospheric layer, just like we see through a glass, water distorted. So the variation due to the change in refractive index of a propagation medium, because of this, signal experiences slight deviation in a trajectory and its propagation speeds as well. So from that you can see in a video, like when it's travel from different atmospheric layer, it changes slight deviation and also change in speed is there. So this is all about a GPS sensor. Thank you, everyone.